Hi, everyone. Welcome to November's early live stream Q&A for Patreon subscribers. I hope you're all very excited as much as I am. Now, we're doing this Q&A a bit early because we're also going to have to do the next month's Q&A a bit early. And the reason for that is because there'll be holiday season upon us, and I don't want you to have to choose between spending time with your drunk uncle over the holidays or watching this live stream Q&A. That's a choice that's too difficult to make. So we're going to move everything a couple weeks up, starting with this Q&A, which is 2 weeks early, and our next Q&A, which will be scheduled for about December 15th, so that we have plenty of time to be able to enjoy both the live stream and the drunk uncle. So welcome, everyone. Let me just quickly check in the chat room. And if you could give me a quick shout out and let me know if you can hear me okay. How's the audio and video before we get started? Excellent, loud and clear, very good. Fantastic. I have a bit of background noise because I'm very near an airport at the moment. So you may hear the occasional sounds of an aircraft taking off in the background. I apologize for that, but we're still going to have a fun Q&A here. First topic of the day, yes, is going to be the Bitcoin Cash hard fork. JJ asks about the Bitcoin Cash hard fork that took place on November 15th. That was the day before yesterday, so we're just 2 days from the moment of the hard fork. And lots of you had a variety of questions about what this hard fork was, how it happened, what happened exactly. So what happened in this particular situation? Bitcoin Cash is a chain that was created on August 1st, 2017. And that chain was split off of Bitcoin. So that was a fork that happened on August 1st, 2017. And November 15th, 2018, there was a second hard fork. So I can give you some of the information of what I think happened from reading about this, and I hope this information is as accurate as I can explain it. Plans were made by the developers who were developing the most common Bitcoin Cash node software, which was called Bitcoin ABC. And this is the software that most of the Bitcoin Cash network was running. And Bitcoin ABC developers decided to add 2 or 3 basic features to the Bitcoin Cash chain in a non-backwards compatible hard fork upgrade. And what happens when you do a hard fork update is that the rules of consensus change so that any clients that do not upgrade to the new rules are unable to follow the chain. And as a result, either all clients have to upgrade or whichever clients do not upgrade essentially create a separate fork. Now, in this particular case, 2 major changes were made. One of them is called op data sig verify. And op data sig verify is a script language opcode that operates inside the Bitcoin script that allows a transaction to validate a signature on an external message. So typically, when you check a signature in Bitcoin script, you can check a signature that is signing the transaction itself, either all of the inputs and outputs, that's called a sig hash all, or some of the inputs, some of the outputs, or just the inputs, or just the outputs. There are a couple of different varieties. But DataSig Verify actually signs a separate message. And what that allows you to do is have, as part of a transaction, a message that comes from an external source, perhaps an oracle. That's one of the use cases. An oracle is a service that provides signed data about external events. So you could use that for a variety of purposes, including to do various sidechain type operations where you have a proof that comes from outside the network. So DataSig Verify was one of the upgrades. And the other one was a change called CTOR, Canonical Transaction Ordering, CTOR. And what canonical transaction ordering does is it changes the way blocks are built and the consensus rules around blocks so that the transactions within a block have to have a specific ordering. Now, in classic Bitcoin, if you want, and the way Bitcoin Cash works before this change, transactions are ordered effectively at a random order with just a few constraints. You can put transactions in a block in any order you want, or the miners can put transactions in a block in any order they want. There's one important constraint, and that is if two transactions depend on each other, meaning they're a chain, whereby the second transaction spends an output created by the first transaction. You can put them in the same block, but they have to be in order, meaning that if you process the transactions one by one, you have to process the parent and then the child. And so they have to be in that order in the block. And that's so you can validate double spends. Now, CTOR, Canonical Transaction Ordering, is a consensus rule change that requires the transactions within a Bitcoin Cash block to be ordered lexicographically, meaning the alphabetic or alphanumeric order of the transaction ID. So they're sorted. And what that allows you to do is a certain type of optimization, which is called outputs then inputs, whereby you can go quickly through all of the outputs created in order by all of the transactions, validate those, and then validate all the inputs. And by doing that, you can do validation of transactions in the future, potentially in parallel, where you can effectively have separate threads or even perhaps separate processes validating transactions in parallel. Now, this becomes an important optimization when you have large blocks, because the ability to validate transactions fast is critical to being able to validate the block. And the bigger the block, the more of a burden that is on validation. So CTOR, Canonical Transaction Ordering, was the second change made by Bitcoin ABC. And both of these were not backwards compatible. However, not everyone in the Bitcoin Cash environment agreed with these two changes. And another group of developers decided that this was not a good direction to take the Bitcoin Cash blockchain. And they proposed another set of changes called Bitcoin SV, or Bitcoin Satoshi's Vision. And the idea with Bitcoin SV is to introduce a block size increase to 128 megabytes per block, an increase in the limit of script operations that can be included in a transaction to enable more complex contracts or scripts within a transaction, as well as the introduction of about 5 different new script operands, which were ones that had been previously disabled, that allow some very interesting complex scripts to be run. These include op-mul, which is for multiplication, as well as op-L shift and R shift, which is for left bitwise shift and right bitwise shift. These types of operations can be used to manipulate numbers in interesting ways and enable more complex smart contracts. So, 2 different groups within the Bitcoin Cash community proposing 2 different sets of changes, both of which are not backwards compatible, both of which require changes to the consensus rules, and both of which create new chains. And as soon as the fork happened for Bitcoin ABC and Bitcoin SV, essentially the old original Bitcoin Cash chain no longer continues. Nobody's mining the original rules. Now, from that moment on, two groups are mining two different rule sets, creating two competing forks, and those are now effectively called Bitcoin Cash ABC and Bitcoin Cash SV, or Bitcoin SV, Satoshi's vision. And there was a bit of a hash war, as some commentators noted, where different parts of the Bitcoin Cash ecosystem were trying to dominate the hashing power within the chain, so that the two chains could really proceed in a way that they competed against each other. And so it was a bit of a competition about who had the most hash power. And there was some discussion about potentially some attacks against one or the other chain, meaning that groups within the Bitcoin Cash environment could potentially mine competitively to cause a reorganization of the other chain in a competition, essentially. So that's what happened. This is the technical explanation of what happened. Of course, as in everything Bitcoin, aside from the technical explanation, there was a boatload of drama and various characters making various threats, leaked emails, forged emails, public accusations, lots of live streams, videos, and podcasts made about all of the personalities and who would dominate over this fight, et cetera, et cetera. Mostly worth ignoring. The end result is that if you had coins on the Bitcoin Cash chain, if you owned Bitcoin Cash in any addresses, then as of the moment after the fork, you effectively now own an equal amount of the Bitcoin Cash ABC and Bitcoin SV coins on the two competing chains. So it effectively works like a airdrop or fork, and you can theoretically now split those coins and keep them, sell them, do whatever you want, and you have a bit of on each chain. There was some drama spillover into the Bitcoin blockchain as well, with some price movement as well as a hash rate decline, as different groups that needed all of the hashing power to engage in this competition in Bitcoin Cash withdrew some of their mining from Bitcoin temporarily. Not really a big deal. The mempool's a bit full right now, and the price went down by 10, 15% or so, which, you know, in Bitcoin terms is what we call a Wednesday. So not that exciting. All right, let's check in with the chat and see how things are going. Eric asks, privacy on the Bitcoin base layer. While privacy on the Bitcoin base layer would be an improvement in theory, wouldn't it prevent the knowledge of whether an inflation bug, such as the recent CVE or common vulnerability bug, being exploited? How would we know there are no double spending bugs or inflation bugs being exploited? Maybe privacy should be better as a layer 2 solution. So Eric has a point here, and one of the concerns about privacy technologies is whether you can still validate the underlying transaction and whether a bug could prevent full validation. The proposed changes to introduce Bitcoin privacy on the base layer involve, among other things, specific technology whereby the values of each transaction are encrypted, whereby the amount that is being created in outputs is encrypted in such a way that you can validate that the amounts add up without being able to see what those amounts are. And this technology is called confidential transactions, and it would usually be combined with some kind of coin join multi-party transaction or mixing transaction. So you have multiple parties creating a single transaction with lots of inputs and outputs, so that you can't easily see the correlation between inputs and outputs. And to prevent statistical analysis, the amounts in the outputs are encrypted so that, again, to prevent statistical analysis. Now, if you encrypt the amounts, how do you validate that they still add up? Couldn't someone create Bitcoin out of nothing inside these encrypted amounts? How do you still do the math, the basic accounting? If you think about it, one of the most important rules in a transaction that the consensus rules have to verify is that the amounts in the outputs are less than or equal to the amounts that were available as inputs to a transaction, meaning that the double entry bookkeeping, if you like, adds up. And the solution to that is what's called a range proof. So when you have an encrypted value that you can't see, but you still want to be able to validate that they add up, we use a cryptographic technique called range proof. And what that allows you to do is show that the inputs and outputs are inside a specific numeric range, so that you can validate that they still add up without knowing exactly what amount they are. And range proofs used to be something that was very difficult to do because it required an enormous amount of data to be transmitted, until a further invention called bulletproofs. And bulletproofs is a much optimized, shortened range proof. The bottom line is this: we can encrypt values on the base Bitcoin layer, and because of the technology of range proofs and bulletproofs, we can still validate that every transaction adds up, that the number, the amounts of the outputs minus the amounts of the inputs are zero. So as a result, we can ensure that there isn't any inflation bug or double spending happening within a transaction. It's important to realize that one of the tricks in this cryptography is to be able to validate, verify without knowing the value itself. So I don't really think we need to move this privacy to the second layer. I think we can prevent inflation and double spend bugs by using things like bulletproofs. Mark asks about Schnorr signatures and UTXO consolidation. Mark says, I'm excited about how Schnorr signatures can improve privacy for multi-signature transactions by summing up the keys so that it looks like an ordinary single-payer transaction. But how does this look like with UTXO consolidation? Does Schnorr also provide increased privacy for the individual? What would a UTXO consolidation with Schnorr signatures look like in a blockchain explorer? So, Mark, no, you can't use signature aggregation, as far as I understand, in order to do UTXO consolidation. The problem with UTXO consolidation isn't the signatures, although we could apply a single signature across lots of UTXO. The problem in that case is that you're bringing all of the UTXO, all of the inputs together as inputs in one transaction, which therefore associates them. Now, if you could construct that transaction to look, or if it is a coin join, so that there are multiple participants sending outputs in multiple directions, and you could also encrypt the values, that would be a useful privacy layer for UTXO consolidation. But on its own, with Schnorr signatures, I don't see how that would provide increased privacy for the individual. Jun asks, what is replay protection? I have no idea what replay protection means. I've heard of this terminology being thrown around during debates about Bitcoin forks. Could you please help me understand why replay protection is important and relate it to an example? Thank you. So replay protection is a technique, perhaps I should call it, or a solution to a specific type of problem, which is if you have a fork and you have two independent chains that arise from a fork, and you have a certain value that you had on the parent fork that now has two child forks, and you want to move the money, but you want to move the money only on one chain. So, for example, in the recent fork, you had some Bitcoin Cash, and now you have Bitcoin Cash ABC and Bitcoin Cash SV, or Bitcoin SV. And now that you have both of these, you essentially have both of these coins controlled by the same keys under the same address, but there are two different chains that track two different ledgers with a common history. So if you want to move, let's say you wanted to move your Bitcoin ABC to an exchange in order to sell it. And you get an address from the exchange, and you create a transaction, and that transaction you transmit on the Bitcoin ABC blockchain. Great. So the Bitcoin ABC has now moved. Now, if there's no equivalent transaction on Bitcoin SV, then on Bitcoin SV, the money will still be under the old keys, the original address, whereas on Bitcoin ABC, the money will now have moved to a new address, and effectively you've achieved a split. You've managed to split your coins or separate the two histories. But if the transaction that you transmitted on Bitcoin ABC is technically equivalent and has no replay protection, then anyone can take that transaction, receive it on the Bitcoin ABC chain, and then retransmit it on the Bitcoin SV chain and have a miner included there. So now effectively, your coins moved on both chains. And you wanted to just move one set of coins, but you've now moved on both chains because the transaction was valid under both rule sets, and anyone can retransmit it to the other blockchain. So how do you stop? How do you stop the transaction from replay? How do you ensure that something you do only happens on one of the two chains, so you can effectively split control of these coins? Once you've done this once you've achieved one transaction that is not replayed, then at that point, the coins will be under different addresses. And from that point on one chain, they'll already be spent from that address. On the other one, they won't, so that you can use different keys to control them on different chains. And you've solved the problem. They now have completely different histories. Effectively, your coins have forked. But until you do that first replay protected transaction, you have a problem. So replay protection can be achieved in a number of different ways. One of the things you can do, for example, is you can have you can use within your transaction some kind of script component that is not compatible on both chains. Let's say, for example, in the current Bitcoin Cash fork, you could have, as part of your transaction, some inputs and outputs that move your coins, and another output or input calculation that used op datasig verify. Now, op datasig verify only exists on the Bitcoin ABC fork, and as a result, if you replay that transaction on Bitcoin SV, it would be invalid because it contains an operand that Bitcoin SV doesn't have. So you would effectively achieve replay protection by introducing some script operand that only exists on one chain. You could do it the other way, of course. You could include an op-mul or op-l shift in the script. In one of the insignificant tiny outputs, you could put a tiny amount against it. And as a result, that would ensure that that transaction was only valid on Bitcoin SV and would be considered invalid on Bitcoin ABC. And once you've done that one transaction that can only be played on one chain, from that point on, your two sets of coins essentially have divergent history. You can now manipulate them separately with different keys and not worry about things happening inadvertently. And that is what replay protection means. if it's not implemented explicitly by the developers in their forking mechanism, then you have to find a way to do it so that you can do a transaction without that transaction being replayed. By the way, replay protection is not something that only matters in Bitcoin. Replay protection was also needed in the Ethereum Classic fork. So in Ethereum Classic fork, the way you do replay protection is actually through a smart contract that has different behavior on one fork than on the other fork. And so you send your money to that smart contract, and it behaves differently depending on which fork you're on. Both forks execute the transaction, but they have a different outcome. So effectively, you've split your coins and achieved replay protection. So the same thing that we talked about before, where you have a script that only works on one chain and doesn't work on the other, you can do with a smart contract that only works on one chain, not the other, or that works differently on one chain and the other, and again, get replay protection. This is a consideration for any blockchain that has these forking characteristics, where you can have a hard fork and produce two incompatible chains. So how are we doing so far? Is the audio and video okay? Can you hear me? Great. It looks like people can hear me. Niraj asks, hi, Andreas. After a lot of investment and extensive research in the blockchain space, it is clear that private blockchain is not having any advantage over existing databases, but still I see a lot of major tech giants working on their private blockchains and offering as a service or in other ways. They're also investing a lot of money in development, as well as in marketing of private blockchain. Is there anything I am missing which private blockchain offers over database, as these tech giants have great talent but still investing a lot in private blockchain? Yeah, I mean, there is one important consideration, which is the hype factor. Private blockchains, the word blockchain itself comes with so much hype, and people automatically make assumptions, often incorrect assumptions, about the characteristics and capabilities of something just because it has the word blockchain in it. So people assume, oh, well, if it's a blockchain, then it must be immutable. Not the case. If it's a blockchain, then you must have decentralized control. Not the case. If it's a blockchain, then it's censorship resistant, or it's neutral, or it's able to track truth, or no one can cheat the rules. None of these things are true. These are not characteristics of a blockchain. They are characteristics of some consensus algorithms on some blockchains. And they're really the aspect of a blockchain that is formed by a decentralized consensus algorithm. So people use the word blockchain in order to imply all of these other characteristics, whether they're true or not, because they can raise a ton of money. And because the consultants who sell this junk to big private businesses, they don't care. I mean, they're going to get funded whether or not the project succeeds. A lot of these are what they call proof of concept, prototype, MVP type projects. And so far, they've been failing in very large numbers. Because developing on a blockchain is complicated, it requires new knowledge and skills, new tooling, and understanding. And if you're going to spend all of that effort, you need to get something in return. Now, if all you're doing is taking, a software clone of Ethereum and you're running it as a private network without mining, proof of authority, with a few nodes on Amazon AWS, in the cloud, etc. That's not secure. Not only is it not secure, it's not decentralized, and therefore it's not immutable, it's not neutral, it's not censorship resistant, it's not any of those things. But it still is hard to do development on that platform. It still requires the new tooling. It still has edge cases that are often unpredictable, like the possibility of forks or mining attacks, as well as problems with propagation of transaction and nodes going out of sync and having to keep upgrading to maintain the software and the consensus rules, all of which means that you've just exposed yourself to a whole boatload of new untested experimental technology to get nothing in return other than a slow, inefficient, decentralized database. Now, there will be applications where private blockchains are relevant. These are applications where the current status quo is a tremendously centralized organization, such as a clearinghouse function. And in those cases, you have a bunch of banks that don't trust each other, or banks, a bunch of financial institutions or parties that don't trust each other. And they will want to implement a type of federated closed blockchain. The problem is that in projects like that, if they try to build their own, then it turns into a standards war. It turns into designed by committee, where every one of the competing parties within this coalition, with this framework, tries to insert their own intellectual property. You have the committee designing technical standards on the front end, while the lawyers are securing patents on that technology in order to get an edge on the back end. You have people trying to introduce their own little pet projects and technical changes in the protocol in order to get some kind of competitive advantage or edge over their competitors. And effectively, the same problem you originally had, which is the reason the parties are choosing to use something like this is because they don't trust each other, ends up sabotaging all of the development effort. One of the interesting things about open public blockchains is that the development is not driven by corporate interests within a committee, federation, or closed industry. Instead, it's driven by either a very large number of volunteers who are developing with different motivations. And in fact, many of those motivations are neutral towards the interest of various corporations that are involved in the development. Even if there are corporate-sponsored developers, they come from so many different industries and represent such a broad range of interests and possible applications that they're not directly trying to influence the protocol usually, and can't influence the protocol to give an advantage to one party. So it's actually very difficult, even in the case where what you want to do is a narrow, federated, closed system, which is slightly better than a completely centralized single party, say clearinghouse or trusted third party. Even in those cases where there is a use case, the dynamics of trying to do this as a committee development or design project essentially undermine the project itself. And we've seen banks try to do these projects again and again and again. I've worked on projects like this. I've worked in financial services on large projects where you had coalitions of banks trying to create the next open standard for payments, the next open standard for cross-country or international wire transfer, the next standard for credit cards or chips on credit cards, et cetera, et cetera. And these standards move very slowly. They either go towards a least common denominator, least functionality model, or they go in the opposite direction of everything in the kitchen sink, where they end up crammed with so many features and capabilities because everybody wants their little pet project to be included, and they fail. We saw this in the telecom wars in the 80s and 90s when they were trying to compete with the internet with closed models of development. We saw this with the development of standards for email that failed because internet email was better and simpler. We saw this with standards for directory services and identity that failed because the enterprise models were way too complicated and developed by competitors jockeying for position. We saw this in the development of protocols like ISDN, the Integrated Services Data Network, which was supposed to be a competitor to internet broadband. We saw this in the development of video conferencing. We saw this in the development of messaging and chat messaging. And in all of these cases, when the industry players tried to get together and create a common set of standards or protocols, they failed. Open source development, open blockchains, public development, collaborative development with a set of neutral principles outside of the purview of the corporate interests that drive these committee developments are more effective. So private blockchains, they're inefficient. They don't offer many of the benefits of decentralization. The cost to implement them is too high. And the chances of these competitors coming together and creating a truly neutral, open standard that actually serves the needs of the industry rather than jockeying for position, they're pretty slim. Let them keep trying. And eventually what we're going to see, as we saw with the era of the open internet, is that eventually companies that said, we can't be on the open internet, it's too wild, it's too insecure, it's outside our control, eventually saw that, in fact, those were benefits. Being neutral, being outside of the control of any organization, having standards that are designed for a broad variety of applications rather than a specific niche, all of these things made it so that companies could get more value by participating on the open internet than trying to build their own competitor. And I think the same thing is going to happen with private blockchains. The intranet of money is a very narrow use case without very good benefits that is actually very hard to achieve. All right, decentralized autonomous society. Kevin asks, you've spoken previously about the concept of a DAO, a decentralized autonomous organization. It's exciting to imagine how the model forces us to rethink the reasons for building organizations hierarchically. Now that we have the ability to draw consensus from a group of peers without the need for trusted third parties, it can truly change the way we think about and structure organizations of all kinds. What is your long-term vision of this concept at a societal scale? How do you foresee our societal governance models becoming more decentralized and autonomous? I'm aware that we are very, very far from this world, so I won't be mad if you end up getting it wrong. Thank you so much, Kevin. So decentralized autonomous organizations and the ability to have people organize in loose short-term or medium-term or even long-term associations where the rules are clearly understood and defined by some kind of neutral execution of a smart contract or a script. Certainly these types of organizations are going to be extremely interesting. I think in most cases, we're going to see these being applied for the narrow case of corporate governance, meaning that for-profit, short-term endeavors, ad hoc projects, loose coalitions, crowdfunding applications like ICOs that we've seen already, but other types of loose associations of investors or small startup type organizations can benefit from this kind of decentralized autonomous organization. I think the term decentralized autonomous organization kind of describes the end vision. And the word autonomous really means that it's not being controlled by individuals, but instead it has a set of rules that allow it to operate on its own. So it's not directed by a board of directors or a shareholder vote. It's a loaded set of words because we don't know exactly how these things are going to play out. And of course, it's a whole spectrum of possible organizational models. You can have things that are very closely held, tightly controlled, but still operate through a set of rules where essentially what you're doing is you're implementing the voting mechanism of a traditional corporation. And the smart contract simply does what an electronic share would do and a shareholder voting system would do. All the way to very, very autonomous rule-based systems where no one really is in control, where the participants get to participate in the organization, but they don't get to control it or change the rules. How do we take that up and scale it to the level of society? I mean, that's very difficult to see from this perspective, from what we're doing right now, because these technologies are still very immature. We're going to have to see them in small scale, for-profit corporate environments, associations, and things like that first. Then you might start seeing these be used more generally for governance and decision making. You could use them for nonprofit associations, clubs, and things like that. And we could see these new models of organizations emerge that, for example, have to do with political causes or charities or clubs and things like that. And then eventually these might migrate to types of governance that have to do with society's function within a geography. So you might see this type of application for, let's say, a municipality or a town. But it's much harder to do when you're talking about geography, because there are better mechanisms for organizing people in a close geography. And at the same time, the problems we have with governance at scale in large geographies like supranational federations, things like the United States or the European Union, or even things like the United Nations, transnational organizations. The problems there are problems of trying to do decision-making at scale that's removed from the people who are affected by that decision-making. And, you know, the real challenge is how do you look at representative governance? Do we need representatives to vote on our behalf, or can we have a more direct model? The difference between democracy and demarchy, where you either have representatives voting for you, or you vote directly in all of the matters that come that influence you. So you might be voting 20 times a day. And again, these are all interesting models to explore. I think we're very far from them. So that doesn't mean the vision isn't valuable. It just means that we have no idea how this is going to play out. And as more and more capabilities become available, as more people use this technology and learn this technology, they're going to find different ways to explore it and come up with ideas that, frankly, we can't even imagine today. Alan asks, what impact will interoperability have on a polychain future? Prominent projects that tackle this problem seem to be Polkadot, Cosmos, Aeon. How does this effort differ from approaches like atomic swaps, decentralized exchanges such as 0x? I'm excited that interoperability could reduce maximalism that certain communities have, just like eliminating nationalism from our world. But what impact will it have on the value that's accrued in tokens if you can smoothly exchange value from a store value like Bitcoin into a necessary token for the amount of service required in the short-term use? This is a very challenging question, and also a very controversial question, because there's a big fight at the moment as to whether our world will be one where maximalism will win out, where certain effects, the Lindy effect, Gresham's law, Metcalfe's network effect, various other kind of cumulative and exponential effects will result in either a concentration of value in a single chain, or a very steep power law distribution where one or two chains take more than 80, 90% of all of the value, all of the transaction volume, all of the users, where we end up in a world that one party dominates. And this happens often in human societies. We see these power laws emerge where one player wins and all of the other possible alternatives essentially gradually fade away or disappear. And this causes a lot of anxiety because people want to know if they're going to be on the winning side or not. To say that people are invested in the outcome of this choice or reality is a literal sense. People are invested. And so people get quite heated over this concept. If you hear people say things like, is Bitcoin the Facebook of digital currencies, or is it the MySpace? This is the concern, this is the fear that people are expressing. If, in fact, this environment plays out like social media did, where you have a very, very strong attraction concentration effect, where the network effects are extremely powerful, and where that gradually creates enormous switching costs. And these switching costs combined with strong network effects lead to a massively concentrated environment like you have with Facebook and social media. Then even enormously powerful alternatives fail. You know, look at Google Plus. It's not just the MySpaces, it's also all of the other companies and groups that have tried to create alternative social media. So that's one perspective. And the other perspective is that the switching costs between all of these different currencies, chains, smart contract platforms, etc., can become so low that they can be handled programmatically, that at least the economic switching costs of switching between tokens will be low enough that you don't have very high stickiness, where users can essentially not commit to a specific coin or chain, but instead they can fluidly move from one to the other as they need. And perhaps in the future, these movements from one chain to another are completely hidden by the protocol. You know, that's the difference between Facebook as a platform and Facebook as a destination on the TCP/IP network. As a destination on the TCP/IP network, there's no switching costs for you to direct your TCP/IP packets to a different destination. You can very quickly and easily access a different website, and that different website has different capabilities. And you can, on the IP layer, there's no switching costs. All of the switching costs are in the invested time of building social relationships and profiles and curating them and all of the content that you've put up on these centralized platforms. If the tokens start emulating our current social media environment, where the investment you have is not just monetary, but it's an investment in relationships and content and other things like that, which are difficult to move, then you can see a pattern emerging where you have concentration. If, on the other hand, really you can have a level of interoperability either through projects like Polkadot or decentralized exchanges and atomic swaps, if it's mostly monetary barriers, then maybe we're going to have a much more polychain, multi-chain, pluralistic world. I don't have the answer to that. Also, when I express an opinion on that and I say, I think we're more likely to have a multi-token world with a power law distribution, but not a very skewed power law distribution, where there are many competing tokens which compete on different dimensions and for different applications. That's not an expression of desire. I'm not saying I want to see that world. I think that future is more likely than the alternative future. I think we're more likely to head in a world of hundreds of thousands of tokens, easily exchangeable, with very low barriers to entry and exit. I think that's how it's going to play out. I'm not saying that's the best way. I'm not saying that that's how it should be. But that's how I think it will play out. Najib asks, do you think there's a possibility that Bitcoin will become the world's reserve currency, essentially digital gold, and that there will be other coins which we'll use for everyday currency? I don't know. And I think that it would surprise me, actually, if Bitcoin could only do and could only fit into the niche of digital gold. I think Bitcoin has characteristics of divisibility, transportability, flexibility that make it much more flexible than digital gold. One of the reasons why gold isn't a good direct medium of exchange is that it's difficult to verify it's real, it's heavy to carry, and the more you make it fungible and divide it into smaller amounts, the harder it is to verify that those are real gold pieces. And so it ends up having this effect where it's easier to assay and verify gold in larger amounts that are stamped by reputable third parties, which creates this entire trust infrastructure. And then the cost of storing and securing gold is so high that it's better to do it in a custodial manner, where you put it in a vault and you have professionals guarding it, and you end up with a little paper certificate, which causes other problems like hypothecation and makes it difficult to use directly as a medium of exchange. Bitcoin doesn't have any of these problems. Yes, there is a greater cost and complexity to securing Bitcoin than some forms of custodial digital money. And yes, that's going to cause some pressure towards third-party custodians. But if that pressure is less than what we have in our current traditional system, where almost everything is third-party custodians, that's still a more decentralized future. And the ability to transport Bitcoin very quickly in very small amounts, and even with second layer networks, even faster and at the level of microtransactions, means I think Bitcoin can be a medium of exchange, a very effective medium of exchange. And if it's a medium of exchange and a store of value, and through use and volume and size, it reduces volatility to the point where you don't see very big fluctuations in price and it's less speculative in nature, then it can also be a unit of account. I think all three of those capabilities are within the reach of Bitcoin. And that doesn't mean there won't be other coins which we use for everyday currency. I think there will be. But I don't think Bitcoin will be just digital gold. And it may become the world reserve currency. I think the concept of a world reserve currency, a unitary world reserve currency, is no longer relevant. I think it will be one of the many reserve currencies that can be used to underpin value on other things. And there doesn't have to be only one anymore. I think that's the switching cost between reserve currencies forces us to only use one. And I don't think we live in that world anymore. We'll see. All right, checking in the chat room again. Vladimir asks, what trends in the Bitcoin ecosphere do you think will be emerging in the long run as the block reward will be getting smaller and smaller? Will there be less miners? Will security be compromised as a result? Will transaction fees skyrocket to support miners, etc.? Honestly, none of the above. I think that as block rewards get smaller, as Satoshi predicted in both the paper and many of his writings, fees are going to have to replace the reward. However, those fees may come from more transactions or more bigger transactions that aggregate things that are on the second layer. And the value of Bitcoin may be very different than it is today. And that may mean that miners can be compensated through that. And quite honestly, if we have less mining than we have right now, if we have less proof of work than we have right now, that doesn't make the system insecure. We've been growing at such a ridiculously exponential rate in terms of the total mining power that, Bitcoin was secure 2 years ago. And 2 years ago, 90% of the mining we have today didn't exist. So we've been going at a order of magnitude increase every 2 years. And at that rate, making the network 10 times more secure doesn't mean that it wasn't secure before. And if we did have a reduction of miners, there are levels of security with proof of work that we had in the past that are perfectly capable of maintaining the security of the network. So I don't think that we have any major problems. Historically, every time there's been a halving, that has affected the long-term price by increasing the price of Bitcoin. And it's mostly been a non-event. The halving is something that you can predict with certainty, but not accuracy, years in advance, and with somewhat accuracy as you get closer and closer to the event. And then, of course, it does happen on the exact block you expect it to happen. So the entire market prices that in with increasing level of accuracy as you get closer to the event. And so do the miners in their operating models and profit models. And it becomes a non-event in the end. I think it's going to continue to do that. Jerry asks, does the Bitcoin liquidity, I think he means liquid, does the Bitcoin liquid sidechain compete with Ripple, XRP, for use case scenarios? So does the liquid sidechain, which is the sidechain created by Blockstream, compete with XRP for use cases? I don't think so. And I think part of the reason for that is, from what I understand, XRP has a very different model in both its consensus layer as well as in how the currency is used within the network than Liquid. And I think people who are interested in XRP are not interested in Bitcoin, even if it's implemented through something like a Liquid sidechain. But there is kind of a spectrum of applications here, whether it's going from payment channels in a Lightning network or just raw payment channels and atomic swaps and things like that, a sidechain like Liquidity or XRP. And there is some overlap in some of those applications. I don't think that overlap is enough to really make these systems compete directly against each other. I think they differentiate enough that they don't directly compete. But we'll see. Conflicted asks about career options. I'm about to graduate from computer science, and applying for big companies is a thing. Open blockchains to me look exciting and promising, yet unstable as a career path. What would you say to a new graduate who sees his friends working for bigger and better paying companies and feels peer pressure to play the game, but sees this space as an important thing and yet is not sure he has enough experience to make a difference? I don't think this is really a question about blockchains. I think this is more a question about following the very traditional career path and building a career with, as Conflicted said, bigger and better paying companies versus building a career that has a degree of independence, entrepreneurial independence, and maybe a lot more risk built into it. I think that as time goes by, these two paths are not what they initially seemed. So it is very difficult, especially in some countries, to be an entrepreneur, to be a freelancer, to work independently of the big career path. In the US, for example, the tax system is stacked against you from the get-go. You pay far more in taxes as a self-employed person than if you worked as a payroll employee for a big corporation. Healthcare is almost impossible as a self-employed person. So you have to handle that too. And of course, you take on all of the risk. In return, what you get is freedom. And to me, that's priceless, but not everyone sees it that way. A lot of people will much rather have job security instead of freedom. And to those people, I would say, those who give up freedom in order to gain a sense of security deserve neither and will have neither, which is paraphrasing Benjamin Franklin. Here's the thing. The bigger and better paying companies that give you this degree of security, it's an illusion. It's an illusion because none of them give a shit about you. There is no career path. There are no guarantees. All jobs are at-will jobs where you can get fired at any time. There's no such thing as a career for life. It's all about developing skills that are marketable and competitive. And as soon as you stop doing that, none of these bigger and better paying companies will be loyal to you. If anything, working for bigger and better paying companies limits the amount of skills that you can develop. You develop skills in playing politics, jockeying for position, climbing the ladder, backstabbing your colleagues, dealing with the sociopath in the cubicle next to you, or your boss, who is also a sociopath, trying to handle all of these internal politics, signing up for projects because they have good buzzwords rather than possibility of succeeding, and trying to figure out not what is a useful thing to do, but what will generate the greatest opportunity for promotion and pay raise within a fixed hierarchy. Those are not really useful skills. They're not very creative skills. And in the end, at least for many people I know, you have a semblance of job security, and in return, you're miserable because your life has no purpose within these bigger and better paying companies. So as an entrepreneur who is fiercely independent, I'm going to give you the worst advice that I possibly can, and that is find a way to do your own thing, create your own job, develop entrepreneurial skills, develop skills that are usable in multiple industries, in multiple geographies, in multiple languages, in multiple countries, and be ready to be flexible. And one of the reasons you should do that now is because later in life, you will not have the flexibility you have now. The older you get, the more responsibilities, the more dependence you have, the less flexibility you have in life. Now is the time to take risks. Now is the time to do something exciting, to try a different track than every one of your peers, and to risk. And part of that means risking that it will fail. And that's okay, because you can fail gracefully when you're in your mid-20s with no dependence. It's a lot harder to fail gracefully when you're in your mid-40s, you have a family of 4, a mortgage, and a private school bill to pay at the end of each month. At that point, you can't fail gracefully. So, you know, the bigger, better paying companies, the selling out to a corporate career of boredom and playing politics will still be there. Try something different. And with that terrible career advice, we are at the end of our November Q&A. Our next one will be around December 15th. I'll be announcing it soon. In about 4 weeks, we're going to be doing our holiday special Q&A. And I hope you all enjoy that. That will be our last Patreon Q&A for the year. Thank you so much for participating. And as always, thank you so much for the support you give me with your Patreon subscription. It makes a huge difference, not just to me, but also to the increasingly large number of people who are working on this project, who I've been able to hire and build this team to do incredible things in this space, to expand the reach of our books, to work in multiple languages, to translate both books, video content, and other things into as many languages as possible and reach as many people as possible around the world. Recently, we had a very successful event in Seattle, which was the culmination of an effort to build a great team for running events, community events, And that project is going very, very well. And again, all of these things are happening because of your contribution, because they allow me to build a team and grow our resources and get this work out in as many ways as possible. So thank you so much. I hope you enjoyed this live stream Q&A, and I will be seeing you in just about 1 month. Take care, everyone.